The topic which we are going to see is the kinetic energy of system of particles. So we all know that what is a system of particle is a system which consists of n number of particles, that is the particles of one, that is m1 m2 m3, like that we can say that is particles mass we can consider as m1 m2 m3 m4, and then each particles moves with some velocity. The particle m1 will be moving with the velocity v1, the particle m2 will be moving with the velocity v2, the particle m3 will be moving with the velocity v3. So what is the displacement with respect to the reference point? That is particles displacement with respect to reference point, it is taken as Ri, and particles velocity with respect to velocity of the ith particle with respect to the distance and the time, it is taken as Vi. So we all know that what is the kinetic energy of a we all know the formula for kinetic energy. So kinetic energy of a ith particle can be written as summation I equal to 1 to n half mi Vi square. So this is the formula which we all know that. So then why we need to calculate the kinetic energy of system of particle with respect to center of mass? Why we need to calculate, and why what is the difference between the normal kinetic energy formula and the formula for the system of particles? That is a thing which we are going to see that. So we have seen the kinetic energy Va. This Va is the compression of the velocity Vcm, that is Vi is equal to Vcm plus Vim. What is Vcm and what is Vim? Vcm means it is the velocity of a center of mass. If we have a whole system, here we had a whole system. This whole system has a center of mass. The center of mass, this is the center of mass. Okay, we are considered a center of mass, and if the whole particle is moving, it will be moved with respect to the center of mass. So that velocity we are calculating it as a Vcm, velocity of center of mass with respect to this origin. With respect to this origin, how the particle is moving, and we are seeing from this point, that is called Vcm. Then what is Vim? Then we have told you that there are n number of particles. Here I considered one particle called as I. Okay, so Vim is the velocity of ith particle with respect to this center of mass. Here velocity we have calculated with respect to origin, but this velocity Vim, it is calculated with respect to center of mass and the particle. So this is the difference between Vcm and Vim. So Vi is the velocity of the particle, it is the sum of Vcm, that is velocity of center of mass of the particle and of a system of particle, and Vim is the velocity of ith particle, that is a particle with respect to the center of mass. So this is the second equation, and summation Ek is equal to summation I equal to 1 to n half mi Vi square is the first equation. Now you substitute the second equation in the first equation. Instead of Vi we are going to substitute what? Vcm plus Vim. When we substitute that, we may get that summation I equal to 1 to n half mi. Instead of Vi, we are substituting Vcm plus Vim. So Vcm plus Vim the whole square. It is in the form of A plus B the whole square. Well, the formula for A plus B the whole square is what? A square plus B square plus 2AB. So we are simplifying in using this formula. So summation I equal to 1 to n half mi of Vcm square plus Vim square plus 2 Vcm and Vim. So we can bring this summation I half mi inside this bracket terms. So when we bring this, the term forms to summation I equal to half mi Vcm square plus summation I half mi Vim square plus 2 times summation I half Vcm Vim into mi. It is left over here into mi, and here this 2 and 2 will get cancelled, and the formula becomes summation I equal to 1 to n half mi vcm square plus summation I equal to 1 to n half mi vim square plus summation I equal to 1 to n mi vcm into vim. So here this center of velocity is with respect to the center of mass. If we are calculating the velocity with respect to the center of mass, then we can say that it is a whole system, not an individual particle. So we no need to consider we don't have the mass for different mass for a single system. So it is a total mass. So we are calculating it as summation I equal to 1 to n mi as capital M, that is the system of a particle with respect to center of mass. So this is the one thing. And next, we all know that if the momentum of mass is should be in equilibrium with respect to a center of mass, now we all know that summation mi vim is equal to 0. So when we are substituting these two terms in the above equation, instead of summation I mi and summation mi vim, when we substitute this above terms, we get the equation as half m vcm square plus half summation mi vim square plus 0. So that is the term, this term will become as 0. This is equal to 0. So when this term becomes, the whole term will become as what? 0. And then why you may think that why we are not taking that summation I equal to 1 to n mi in the second part as capital M. This is the whole system mass and this is the mass of individual particle. So we can't take it as a capital M. So the kinetic energy of system of particle is half m vcm square, that is kinetic energy with respect to velocity of center of mass. And second one, it is half summation I equal to 1 to n mi vim square, that is kinetic energy with respect to velocity of ith particle, velocity of the ith particle with respect to center of mass. So that is that this equation, this is the equation 4. This equation is the equation represents the kinetic energy of system of particles. The equation 4 represents the kinetic energy of system of particles. So in this kinetic energy we have two parts. One, it is half m vcm square. That term represents the kinetic energy of center of mass of a system. And another term is half summation I equal to 1 to n mi vim square. This is sum of, here it is a whole system. Here it is a sum of kinetic energy of individual particle with respect to origin. So this is the formula. This is the formula for kinetic energy, and these are all the explanation. Thank you.